geobyte.
Look at the another important question, concept oriented question, asking like this. Three stars A, comma B, C have surface temperatures Ta, Tb, Tc respectively. Star A appears bluish. Star A, let me write it clearly. Star A appears bluish, and star B appears reddish, and star C appears yellowish. Then what is the temperature? What is the temperature relation? What is the temperature relation? You know, Wayne's law, right? Wayne's law says that the mean wavelength, that is maximum mean wavelength into temperature equal to a constant B. From this, since B is constant, mean wavelength, right? Maximum wavelength into T equal to B means B by T. From this, maximum wavelength is inversely proportional to temperature. Okay, as you know, for appearing the star bluish, it must be maintaining the minimum lambda. Okay, now for appearing the star yellowish, it must be maintaining mean lambda, and this should be maintaining maximum lambda, mean wavelength, and it should be maintaining mean wavelength, average mean value. From that I can say that the lambda for uh, B, okay, lambda for A lambda for A is less compared to lambda for C. Let me write it clearly. Look at the diagram. Lambda for A is less compared to lambda for C, less compared to lambda for B. Since lambda is mean wavelength is inversely proportional to temperature, from this I can say that TA is more than TC is more than TB. That means for appearing the star A bluish, it must be maintaining high temperature. Similarly, for appearing the star B reddish, it must be maintaining minimum temperature among the given temperatures. So TA greater than TC greater than TB. Therefore, option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. The quantities of heat required to raise the temperature of two solid copper spheres of radius R1 and R2, given that R1 equal to 1.5 times the R2 through 1 Kelvin are in the ratio. You know, the change in temperature delta T is equal to 1 Kelvin. It is asking the quantities of heat required to raise the temperature of two solid copper spheres. That means specific heat S remains constant. This remains constant. Then what is the rate of heat transfer? As you know, rate of heat transfer del Q by delta T equal to M into S into delta T. Here small t is for time, capital T for temperature. You know, specific heat constant, change in temperature constant. Here the rate of heat transfer del Q by del T is proportional to is proportional to mass. But what is the mass? As you know, density rho equal to mass by volume. From this mass equal to density multiplied by volume. It is given that the two solid spherical, right, bodies. For a spherical body, volume equal to 4 by third pi r cube. Therefore, mass equal to density multiplied by volume is 4 by third pi r cube. Right? Let me write that value. Del q by del theta, del t is proportional to mass equal to rho into 4 by 3 into pi r cube. From this, I can write that the rate of heat transfer del q by del t is proportional to r cube only, because rho remains constant, 4 by 3 pi also constant. Then I can write that the rate of heat transfer divided by r cube is proportional to 1, or del q by del t divided by r cube remains constant. Okay, so that can be also written as del q by del t divided by, right, divided by r1 cube for the first case must be equal to del q by del t for the second case divided by, second case is second rod, divided by r2 cube. From this, del q by del t for the first body, that is rate of heat transfer, divided by del q by del t for the second body is equal to r1 cube, r1 cube, not r1 square. Look at the r cube. Should be very careful. R1 cube, right? R1 cube divided by R1 cube divided by R2 cube. Otherwise, I can write R1, okay, R1 cube by R2 cube. It can be written as R1 by R2 whole cube. But given that R1 equal to 1.5 R2, it is equal to 1.5 R2 divided by R2 whole cube. Okay, so it is equal to 1.5 by 1 whole cube. That can be written as 1.5 into 2 divided by 1 into 2 whole cube. It is equal to 1.5 into 2, 3 by 2 whole cube. It is 3 cube by 2 cube. 3 cube is 27. R cube is, 2 cube is 8. 27 by 8. Look at the options. Look at the option D. Option D is absolutely correct. Understood clearly?
Geobyte.